Hello, hello. Well, we are live. 1 minute to spare. Welcome to the Copenhagen Developer Conference sauna. I hope we're all going to feel nice and warm by the end of the session because I know I am. So, I'm here to talk to you about intentional code. And really what this is a response to that feeling you get when you try and use a system and you try and fix a system, and everything just kind of fucking sucks. And everyone's kind of been there. There's just this horrible feeling where you try and maintain a piece of software and you open it up and you're peeling away layers upon layers of kind of needless abstraction that seems to give you nothing just to find that one file with the 4 lines in the middle that actually does the work. And we all have systems like this. We all own them, and like it's pretty tedious and it scares me. So this is hopefully a bit of an antidote, a bit of a salve to that horrible visceral pain. So we're all going to feel it together. So my name's David, and I spend a lot of time thinking about software design. It's kind of my toxic character trait. So I'm the head of architecture for a company called New Day, based out of London. And I'm really here to talk to you about why design itself is important and why every single thing matters. The truth is, I'm a programmer, and you're going to pry my keyboard out of my cold, dead hands, regardless of the job title you stick on top of it. So it doesn't matter what kind of role that you hold in your technical organization. This is really for you. With that said, there's not a lot of code in this talk, because what I really want to think about here is software design. That's what I want us to be considering. Now, I did a bit of a small viral tweet, a viral X-zeet, that same joke at the end of last year that seemed to resonate with a lot of people. So I was trying to fix this pretty architecturally awful code base, and as soon as I opened up my IDE, my heckles were raised by this god-awful organizational pattern that you'll see here. So I did what I always do when I see something I hate. I opened Twitter and rage tweeted into the void to make sure that everyone felt as bad as I did about the thing. And I remember just sitting there thinking, this is like a damning indictment on the state of software design in 2023. So Twitter obviously agreed at the time, but mostly the thing that really jumped out at me when I was looking at this code base was really how shitty and thoughtless it all was. It was all really, really thoughtless, this organizational pattern. Organizing code by architectural feature is like way up there on the lists of horrible hate crimes you can do to your software. It's something that has no real meaning, and it buries everything. And you sit there and you think, why would someone do this? Well, there isn't an answer. That's the problem. There is no why. So hopefully throughout this session, we're going to try and answer the question, why is everything like this? Now, as the joke goes, organizing your code by architectural feature is exactly this picture. It's taking a classic car collection and splitting it up into tires, windscreens, bonnets, and engines, and saying, come and enjoy this. Now, so much of talk about design when we think about software and the form of code always ends up getting dragged back to the work done in the 90s, mostly, about design patterns. Now, this isn't a talk about design patterns, but I want to pay them a little bit of lip service and due respect, because it might perhaps be easy to misinterpret what I'm about to say as some horrendous tirade against design patterns. And whenever you say design patterns are bad, everyone gets very, very angry and the pitchforks come out. This isn't a cry against standards. It's not a cry against patterns. But first, we have to understand what design patterns really were, because I think what people call them today are really not what they were intended to be. Now, design patterns themselves originated in the works of Christopher Alexander, who was like an actual real-life building architect of buildings that weren't allowed to fall down, who wrote this beautifully titled book called Notes on the Synthesis of Form, which is also the name of my progressive death metal album, I think. And it was consumed by computer science researchers throughout the 70s and 80s, including specifically people like Kent Beck and Ward Cunningham, who around the 80s started writing about pattern languages in software design. Now, you end up with things like the Gang of Four book that came out in 1994, and it's probably the foundational text that talks about design patterns in software. And what it did is it attempted to lay out a series of structural, creational, and behavioral patterns as they were observed in common software of the era. And that's really important. Like, they were looking around themselves and identifying things that they were seeing. There were a bunch of other books that followed, things like Kent Beck writing Smalltalk Best Practices, and the classic Martin Fowler Patterns of Enterprise Architecture that everyone read in the year 2000 or then about. But ultimately, the intention of all these books was exactly one thing, and it was to provide concrete guidance and description of common solutions to common problems. They weren't saying, here's how you should build things. They were saying, here's how we have seen people build things. And that's what they really are. Like, design patterns are an aspect of language. What they're trying to do is give model answers to model questions and provide names for things that you see so you can talk about them. And that's like super, super valuable work, right? Like, if you don't have a name for things, you can't describe it, you can't communicate about it. And so much of what we do in software is lost when we really end up with lots and lots of names for the same things. So, this isn't a talk about design patterns, but all that work was really good work. Categories of problems that are the same. This talk is about everything that isn't the same. Now, I suppose I just kind of lament the fact that most talk of design in software is kind of grouped up into this talk of design patterns, because they're really the least interesting part, all the stuff that everyone does all the time. If design patterns are about the parts of the systems that are familiar, and with the acceptance that, we push programming languages to innovate over time, hopefully the theory goes that our programming languages should make some of these design patterns from the foundational works basically obsolete at this point. Right? It feels like we kind of forgot to really talk about everything that wasn't predictable or common. And, really, design patterns are kind of bug fixes for gaps in your programming languages if you have to do the same thing over and over again. And that's where real design starts, when the talk of patterns end and you're just left with trying to work out what to do with the rest of everything that is your actual software. Now, on the other end of the spectrum, we have kind of large-scale architectural discussions and conversations about design. And you end up just seeing the usual suspects of stuff like N-tier, hexagonal architecture, 12-factor apps. Now, these all try and offer prescriptive rules around how you should arrange the form of an application. But I think kind of software design has more than just those two axes of functional patterns and large-scale architecture. And I think all the most interesting parts of software design are the incidental moments about the way the programmers interact with their code. It's the every other line, it's the day-to-day. It exists in the gap. So here's the funny story. Back in the depths of time, I was an art student, like painting and stuff. But more importantly, I also studied literature and English language and design and fine art and painting in the 90s in high school. And I specialized, we're going to go with that, in literature and politics. But I always wanted to be a programmer. And that's because computers were like magic, and they were exciting, and they were making things, right? But for the first half of my career, and when I was learning for that kind of first 10 years in high school, I just really struggled to reconcile this aesthetic sensibility of design with the works around design as it was kind of rendered into programming, and all those books about design patterns. They just seem to have a completely different aesthetic viewpoint than I was used to. And I then went on and did a computer science degree after coming from this pure arts background, which I didn't particularly enjoy. But during the first year of comp sci, I came across Donald Knuth, like every first-year computer science student. And he wrote the famous series of books that are still being written, The Art of Computer Programming. But he also wrote about this concept that he described as literate programming, which was a book he published way back in 1984. Literally, the year I was born, so no new ideas in computer software. Now, Knuth had tried to get traction in this space around the idea that software should be written by combining a programming language and a documentation language. And they both were combined and run side by side to produce the source code. He was really obsessed with this idea that your software should be read like a book. And, the funny thing is, like, having this kind of artsy approach to it is very consistent with someone like Donald Knuth, who spent 10 years writing texts so he could write a book. He's like, he must be the king of yak shaving at that point. And, if you think about it, the languages that Knuth was talking about at the time in the 70s really were a lot more primordial. We'll go with that. They were a lot simpler. They were a lot more structured, a lot more rigid, and less expressive than the languages we have today. And actually, modern programming languages are an order of magnitude closer to what he was dreaming of when he thought about literate programming, about things that were legible and could be read by humans rather than just machines. He was kind of right, and he was vindicated by subsequent 30 years of development into programming languages that dragged programming languages into a more expressive form. And that core idea really resonated with me, the thing where he was like, oh, well, it should be like the index page of a book and you flip through the pages. I was like, you know what, yeah, software, it really is the same as literature. It really, really is. And this was a little bit of a revelation to kind of baby programmer me, because it totally changed the way that I started writing code, because I started specifically optimizing for that thing, because I realized that software only became good literature if you treated it like good literature and tried to arrange it in those organizational patterns. So over the years, I've come to this real precise definition of what I really think software is. Software is a constrained form of communication between programmer and programmer that describes concepts and problems, but also happens to be executable by machines. And I've thought about this a lot, and I think I believe it. It's probably a hill I would die on. And the more you think about it, the more it starts making sense. You spend so much more of your day reading code than you do writing it. Your code exists in a context. It has subtext. It has authorial intent. Your code has flow. It has form. It has rhythm. It has tone, just like any other writing. Sometimes the authorial intent is not what gets rendered into the screen, and that's kind of where bugs come from, right? Like, the analogy works. But most importantly, your code has reason. It has a reason for existing. It has intent. Now, here's the bit where everyone gets to be mad at me because I tell them to burn books, and burning books is heresy. Burn your copies of clean code. It's the book that everyone always cites as the foundational work on software design, and it's aged so poorly. It means we don't have to deal with problematic family members. It's an extremely dogmatic book. And its presence in the industry, honestly, has kind of muted so much conversation around design to conversations about naming variables. It's muted conversations around architectural style in the same way that people just chanting solid principles in every interview has kind of muted every conversation around what good structure looks like. Its shadow is long, and it's thoughtless and kind of full of dogma when you follow it blindly. Now, as an aside, on another occasion I've done this talk, people said, oh, but don't you think everything exists in a context? And I think there's probably some value to that. I think this book was very important to a lot of people at a certain point in time. It certainly was to me when I was early on in my career, but I think we can grow past and learn from all the works and move on. So I hear you scream heresy. You can't say that about clean code. But, I think instead of this notion of cleanliness and this weird, like, craftsman metaphor that series of books really focuses on, I've really come to value intentionality in my code above any sense of syntactic cleanliness the more I think about this. And, intentionality is a fairly abstract word, so let's talk about what I really mean by that. I mean, literally every single character on the screen matters. Every one. If you think about this as literature and as work, I want you to approach the work as if everything is important and everything has to have meaning. Every choice you make is a choice you're making. The white space matters. The rhythm of the code matters. The naming obviously still matters. Form matters. Function matters. And code written with thoughtfulness and intentionality that are written for a reader matter more than anything else. Now, thinking as your software as literature like this kind of lets you value different ways of communicating in code. So we can communicate on the kind of the macro scale with organizational patterns and application architectures. So let's take, for example, MVC. MVC is an organizational pattern. It dictates how you split up your code with all of its common implementations, and it basically tells you where to put your files, right? Now, MVC is a weird pattern that I have a love-hate relationship with, because what MVC does is it totally obfuscates the intent of your software. MVC is an organizational pattern is most popularly used for web applications in 2020. I look at an MVC code base, I see a website. I don't see what the website is about. It's hidden completely. And it's a good example of an organizational pattern that is useful in one axis because it helps people understand how to maintain their software, but actually it obscures a lot of the intent of what it does. So all I know is how the code base is wired up when I look at the MVC application. Now, I actually find the micro scale much more interesting than the macro scale, where the way that you form code from function to function or module to module telegraphs intent. Because, of course, we use form and flow to increase cohesion in our code base. It's that same old axis of like cohesion and coupling being these two things that you get to play around with in design. Now, by way of an example, and don't worry about the details here, I'll talk you through them, of what I mean when I say use form, flow, and cohesion on the micro scale. I want to share two screenshots, ironically, from that same code base that you saw before. Now, here's a relatively ugly, mundane function. It does some HTTP stuff, like what it does isn't super interesting. But what it is it's really difficult to read. And it's really difficult to read because there is no form or function or flow in this code. It forces your brain to comprehend software literally one line at a time as statements. Now, we use paragraphs in text to guide the reader, to group related concepts by moving things together before moving on to something else. Code is the same. What you're doing when you start to reorganize code is give the reader something to lead through, to read, to pause, to breathe with. Lines mean something, and if you use them everywhere or nowhere, you've removed the intent. You've taken away a whole form of expression from your code. Now, this is like a really incredibly small-scale example that does great injustice to the effects of kind of code with good form versus code with bad form. But code with good form is like poetry with rhythm. It reacts to a reader, it directs a reader, it telegraphs how they're meant to understand it. It shows you what's related. Significant things are grouped. The things on the left are more important than the things on the right. Its aesthetic sensibility reflects how the form of and the flow of control of the software is designed to be interpreted. And that's the interesting thing. And all I did was deleted some lines. Like there was nothing big that happened here. But what I did is I spent time looking at it and thinking about how I wanted someone to comprehend it. Now, the form and flow of your code is something you use to communicate, and it's often lost in this kind of morass of linters and auto-formatters that force a regular form without any concept of context onto your code base. Form is intent, it's design. Now, the more I started thinking about software through this lens of literature, through this lens of intent, the more it became really apparent to me is that what I was really reacting to was the inherent complexity of a lot of modern software. That your job as a reader is to kind of load this context into your head so you can comprehend the work, and then you can make a change. And what I was really doing was craving this clear communication of a clear piece of written prose, of meaningful code. And that was really this horrible grander design problem. Now, I've been working on a sentence recently, and I think it's up on the screen. I can't see the screens from here. And it's ridiculous to ever be working on a sentence. Watch your life work. I came up with some really cool short phrases. And it's this. It's, I believe that the real central point of design is that the complexity of any application you build should be at most as complex as the problem space it inhibits and no greater. Macro and micro design are tools that we have to meet this goal, and just so many systems straight up fail this thing. And anytime you've opened a thing and you want to change a line of text on a screen in a mediocre, mundane web application, and you have to peel away layers of abstract factory, builder, renderer, view model, God knows what else, I want to fucking kill myself, right? Like this is the horrible bit, right? It's the worst thing. And systems just fail that sniff test because all of the important work is in a tiny corner buried in everything else, right? You're completely hiding the work. It buries systems, it makes working with them like swimming through treacle, and it's often when people over-design. They apply too much design to a small problem space. And it's kind of like we forgot how to build small programs because we basically drank the Kool-Aid of decades and decades of best practice that told us we needed all of these things in every system without stopping to think that maybe we don't, and maybe actually we only have 3 problems and we could just solve those. Right? Really interesting. Like, I love beautiful, tiny programs that do way more heavy lifting than they have any means of doing, because they're so small and perfect, and they totally encompass a problem space. Now, the interesting thing about thinking about design like that, and even using the word design, is that design can be thought of as contentious. You know, much like software architecture is like a building analogy that we put on our domain, design is a visual skill that we use to communicate information. You know, designs exist to solve problems, to communicate intent, again, using form and function. That's why design is different from art. But design is also temporal in nature, real, regular design, with many designs only really making sense in the context of their time. And, you know, even sometimes if great design can be timeless anyway. Now, if you look on the outside of software, great design is really deeply contextual. Now, there are plenty of examples of products where great period design applies, but they're nonsense now. So if you look at these pictures, like these two designs are completely 100% obsolete. They're dead technology. We don't use any of this stuff. And a lot of our legacy applications contain design patterns now that are as obsolete as using these things, and haven't kind of changed with the systems and the context changing around them. Now, there's a really interesting observation here, that taking those two particular iconic designs as an example, you might think these products don't exist anymore, but they weren't actually the last of their lines. They evolved and changed over time, and ironically kind of converged. And it's because design is always iterative and it's always context sensitive. Like, phones didn't cease to exist, Walkmans didn't vanish. What actually happened is they were iterated out towards touch phones and MP3 players and mobile phones and Discmans and iPods, and all those things converged. And, you know, they actually converged because we discovered there was a beautiful generalization in those two designs, and we weren't really trying to play music or make phone calls at all. We were just trying to transmit audio, right? And actually it's all the same problem, and that's great design. Now, I find it really interesting personally when I look at like real world design to see that iterative step-by-step process, because I think it really neatly reflects the iterative process of kind of TDD and test-driven design similarly, right? You know, I'm sure you'll see like the rising trend of people that have criticized TDD because they don't understand it. And whenever I see people criticizing TDD, the main thing that always screams at me is they always kind of say, oh, well, I had to write the test first, but I already had the thing in my head and I didn't get anything better, and it seems like a waste of time. I was like, yeah, but the TDD thing is like a red, green, refactor, iterative cycle. And if you're not doing the iteration, you're not really doing TDD. You're just thinking of a thing, holding that in your head, and then trying to test your idea, right? Like, the iteration is a fundamental part of good design. And, you know, one of the things that I'm absolutely certain of is if people think that that cycle is redundant ceremony, they've never actually really felt it work for them, and they've never really iterated on their software. So this also highlights one of the other really kind of magical qualities of design as a discipline itself, which is that it's just as much about form as it is about function. There are like entire categories of problem that I personally believe you can't feel until you see it. And one of the coolest things about TDD as a discipline is that when you see the APIs that you've kind of driven out, you can look at them and go like, oh, I don't really like that. It doesn't feel right. I feel like when someone reads that, they're going to be confused. Like, that kind of extra level of visual reasoning that you get from looking at a thing and interacting with it is super, super powerful. And I think, you know, it's not that I'm saying that without iteration you can't build beautiful things, but I reckon you have to be a lot smarter than I am, because you're missing this entire category of signal of being able to use a malleable thing. Now, I appreciate there's kind of a common trope that programmers are not visual people or don't feel like they are, but it's precisely those visuals that give you the ick when you open software. You might not think you're visual, but if you open a code base and go, oh God, who did this? That is you responding to visual signal in real time straight away. So, looking at this framing device, looking at software design as actual design, it's probably worth us thinking about the context that modern software exists in and how that might challenge some of our more conventional approaches to design. It's kind of worth us reevaluating all of our organizational patterns to kind of exist in this world where we're not building software that ships on DVDs for desktop computers running MS-DOS and Windows 95. Because all of the books about design patterns were written when we were doing those things, and looking around the room, I don't think many of you are old enough to have ever done that. Now, I'll tell you what, all of the 10th generation clean architecture people really absolutely hate people talking about. Most of the things that you describe as best practice are just kind of overblown structural design patterns normally. Sorry. And they kind of look almost as silly as organizing by architectural feature on sufficiently small size systems. Like I see a lot of system design these days where these ideas have been fragmented into microservices. Who am I kidding? It's always distributed monoliths, always, every single time. And you know, the individual moving parts of those systems have then been absolutely decimated by best practice. Because like, cool, you need to solve 4 problems. So you split them up into 4 systems, and you make 4 repositories and 4 sets of CI tools and 4 sets of automation and 4 target production environments times by 3. And oh my God, I now have fucking 300 problems. Right, and this isn't me saying just put all your code in one place. But what it means is when you zoom out, it looks like best practice. We neatly separated our concerns. Well, high five. So I want to show you an example of another application that I was trying to fix that suffered from exactly this. And you're definitely not going to be able to read the slide, so don't worry, just look at the number of things. So this is a class diagram that I generated from a system I was building that was following a prescriptive clean architecture pattern. But all I see here is complete dogmatic thoughtlessness. So the system, which was being recompacted back down into a single logical application, was divided into a huge number of modules, all of which were further subdivided by architectural feature, and each part of the application had its own web app and a module and some core libraries and a function and 8 different directories. So they all looked absolutely identical, right? And the total cognitive load of being able to rationalize what any of this stuff was doing was absolutely huge. And I think it was well-intentioned. Like, someone wasn't trying to make a mess. But all I see is an explosion of complexity because all of the invisible things really, really, really damage the surface area of the software. And the obvious big comedy bit is it was all maintained by one team of 4 people. So I don't get it, right? And the irony is, for all the macro design that was going on, the project structure, the code, like, this is a diff of me cleaning up one file from the big load of mess to like 4 lines, right? Like, this is where we ended up. The state of the actual code was horrendous. It was all like copy-pasta guff. It was horrible. And all that effort was focused on organizing files into folders rather than focusing on the code that really mattered. So, you know, it was horrible, and I see things like this all the time, and I know everyone has systems like this. So how did we spot and fix this? Well, we did the first thing I noticed, actually, was all of these systems were being deployed to the same application service group in Azure. They were being recombined at the end of all of the work, which was like the canary in the coal mine of weird design. So we did a first round where we trimmed away a lot of the complexity. We collapsed all the families of libraries together. And rather than a web application depending on a module and a core thing, they at least now were just directories in the same application. So we merged all the things back together. We then went through all the organization by feature, and we co-located all of the things that were only used in one place to live inside the code that was calling it. And then finally, once we'd rationalized all the code base down and folded it in, we had 12 applications that we just deployed in a single job, and then we cut and pasted all the stuff from all 12 into one and deployed at one time and rerouted all the URLs, deleted all the code. One single application. So after the work was completed, we went from 64 independent moving parts with 19 build pipelines times 3 for each of our environments into a single deployable application that we could fix by systematically removing low-level code rot using just standard old refactoring tools. And this is what I believe adhering to these really, really super strict kind of clean architecture organizational patterns actually lead you to if you don't really, really need that complexity. And again, I'm not saying those architectures are all bad. I'm saying make sure you have a problem that requires them before littering your system with them. Build smaller things where you can. Now, there are obviously certain problem spaces where there are known good structural design patterns, and that's cool, not a problem. The most obvious example is kind of RPC-style systems with HTTP API calls. Now, they often map really neatly to kind of command, query, pattern classes. That totally makes sense, right? They're good, rational organizational patterns. But in those systems where you have known good patterns, it's really important that the form and your flow of the individual implementation matters even more. I guess what I'm reaching for is it's not just what you say, but how you say it. And it matters because when your macro-level design all fits a well-known pattern, you kind of get this code blindness when you're reading, right? And you start to skim and you start to not really read. And it's important to me that we use the low-level details to actually communicate what is different and where people need to be paying attention. In fact, when I learned about MVC, I made this mistake. Everything was an MVC app, right? I suffered from this affliction for a lot of my career. I thought everything was a controller. Then I learned about aspect-oriented programming, and everything was an interceptor. And I'm like, cool, I've got my new shiny toy. I'm going to do it to every piece of software. I built a few DI containers, and I decided that everything could be injected using DI and some clever factory logic. Definitely did that. This is my penance, I think. I then learned that controllers only dealt with HTTP, so then every piece of logic became an application service. Right? And I desperately, in the middle of my career, tried to find the good shape, the answer that everyone would be happy with me for. And I also, when microservice design first got popular, blew up 100 systems into lots of moving parts, right? Like, we've all done this. We've all made these mistakes, and it's cool. But it takes some time from having lived with these systems that you've made these mistakes to learn where your designs fail. And, it takes time to learn that uniformity is actually the opposite of expressiveness. By trying to force everything into the thing I liked the most at the time, I stopped letting the programs breathe and look like the things they really are. So to me, it's really important that when different parts of your system do things that are different or break a pattern or a mold, they look different. Because then when I'm reading through the code, I'm like, oh, cool, well, the style has changed here, the API has changed here. This is something I need to pay attention to. It's optimizing for the reader using visuals to lead the eye. It encourages reading instead of skimming. And we're going to talk about complexity a little bit here. Now, I kind of have come to believe this idea of intentionality is the inverse of complexity. It's the stop doing things just because. It's stop cargo culting design decisions. If you don't understand why you're applying a pattern or a structure to your code base, you should really stop doing it. And actually, once you get that mindset on every choice you're making, every library you're adopting, every tool, every framework is additional complexity, right? And if you can't justify that additional complexity of picking up extra moving parts, you should stop and think about it. Now, unfortunately, because so much software today is really context sensitive, there are many times where blindly applying design patterns makes software much more difficult to reason about. And what you're really doing is you're increasing cognitive load, right? And the job of design is to decrease cognitive load. So I want to go through some techniques that we can use to remove cognitive load in our designs. So when I talk about complexity, I often discover that lots of people have different ideas of what complex really means. It's a kind of an overloaded word. So I read this really great book called A Philosophy of Software Design by John K. Oosterhout. And I think it really gets to the heart of like a great definition of what complexity is in software. I'd really, as an aside, I'd recommend the book, but its second chapter is specifically about complexity in design, and it's really, really very good. And the second chapter describes how software complexity isn't like picking the wrong framework, generally. It's caused by tiny paper cuts and tiny bits of cruft that accumulate over time rather than a catastrophic design error. It's from the collection of dependencies and obscurities and idiosyncrasies at work. That's where complexity comes from. So Oosterhout describes complexity as the thing that leads to what he describes as change amplification, which leads to high cognitive load, unknown unknowns, and then an explosion of work and effort, which subsequently leads to the number of modifications required to make any change high. So that's kind of your indicator, right? Like if you're making lots and lots of modifications to change a system, it's a complex system by design. So building on that definition, I think that intentional, thoughtful design is this kind of salve for the creeping rise of complexity surrounding software. So there's a distressing realization when you reach this line of thinking, which is that design patterns are precisely popular because of exactly that thing I was searching for in the middle of my career. They give people a really easy, nice green tick of a goal to head towards. Like they give you something you know is good, like there's an answer, like a real definite answer to what good looks like. But once you've seen enough code bases in enough languages, you kind of realize that most of the arbitrary stylistic quirks of those environments are just that. They're kind of fine. You don't really need to worry about them. People get lost in the detail. They're mostly irrelevant. So what I've come to believe is that good code is a couple of different things, right? Good code is code that's easy for someone with minimal domain context to read. So code that your average developer can understand is good. That's easy. Code that focuses on developer experience, debuggability, and usability, right? Code that you cannot debug meaningfully is bad code. And code where the intent of the software, the thing that you're doing, is lost in the visual noise of the programming languages and tooling and frameworks is bad code, right? So code where there's more syntax than there is operations that mean something in your program, bad code. So regardless of language or style or intent, all programmers really interact with code bases the same way. What you do is you glance at it to understand it, and you go through what it does, and then you read it intently to understand how it does it. You kind of go through this rapid cycle of like, what is this? What am I doing? How are you doing that? Good code, regardless of style, makes that process super easy. Now, at a meta level, all code is constructed from abstractions and encapsulation. Like these are two very, very common terms. And this has always been true. So the programming languages, runtimes, and frameworks that we write code on top of help go through an enormous amount of kind of compilation, translation, interpretation to let you write your applications. Now, the programming languages themselves are common abstractions over operating system APIs, which are abstractions over hardware, which are abstractions over assembly languages and CPU instructions. Like, this trend continues upwards, right? And your goal in your application and library space is to write increasingly narrow abstractions that provide additional value. Now, for the most part, we get to be blissfully unaware of this huge amount of work that we're building software on top of. And that's because the value that those abstractions bring vastly outweigh the amount of mental effort we have to go through to comprehend them. Right? So the obvious example of this is you never really worry about what file open does. But like file open is really, really complicated in every programming language, in every runtime, on every platform. There are a lot of spinning disks, there's SSDs, there's memory mapping, there's file systems, there's God knows what, right? But as a developer, there's a really, really beautiful, neat, constrained abstractions of folders and files that exists for you to interact with. Right? Beautiful, actual beautiful design. As you implement your own software, sadly, it's not always the case that the abstractions that you introduce reduces cognitive load, right? Like getting to that beautiful point is really difficult. And it's often a very subtle process to understand exactly why one abstraction feels right and one isn't. So I'm going to borrow a little bit more from that book, a bit more terminology. So when we think about this example of file open, I want you to consider the idea of a module in software. Now, it doesn't matter what programming language you work in. We have modules, and modules expose functions, and they have some kind of API that we work with. Now, the interface that a module exposes represents the complexity that module imposes on the software that consumes it. So the more stuff you can do with a module, the more complexity you introduce to your code base because the problem space opens up. So the smaller and narrower the interfaces that you expose by your modules, the less complexity you force upon the software that consumes them. By that description, you can think of the best modules you can build as deep. Now, file open is a really, really beautifully deep module. It has a very, very narrow interface that trades in its own types of files and directories. You don't know about hard disk blocks and the file system and God knows what else. And it's very, very deep because it completely contains all of that detail in a nice abstraction. So modules that offer deep functionality through a narrow interface are desirable and reduce the cognitive load as you're building software. The inverse then is often true. So an interface with lots of functions or a module that exposes lots of behavior and lots of parameters and lots of types out of the top forces that complexity up onto the software that consumes it. And that makes your design worse every time you do it. Your software degrades in quality. So as much a factor of avoiding the wrong abstractions is really finding the right ones, okay? And it may seem like really painfully obvious advice, but abstractions and generally like any other module of code that you find should contain their problem space entirely. That means that abstractions that include things like pass-through methods, and like I've seen so much code where you're just brain deadly passing things through. I've written that code myself. What they're doing is every time you do it, you increase the complexity, right? You're not gaining anything, you're only losing. Our software is riddled with thoughtless abstraction and poor encapsulation. And every time a design decision like that is made, it decreases the reason that the module exists or the piece of software in its entirety. So anything that adds a large amount of boilerplate code to an application by this measure is bad code. Now you get to a certain point where you realize that all this talk about kind of design and dogma, I guess, dissolves into kind of absolutism and people searching for that one concrete good answer. Because I can tell you one truth here, which is that any design, when stretched to its logical extreme, becomes nonsense. And it means that you can look at systems that were beautiful at one scale and make no sense at another, and that's totally fine. Designing software with intent, software that survives, really is an exercise in compromise and trade-offs, and it's really why anyone with experience in designing software always says it depends, right? It's the answer to every design question is, well, I don't know, it kind of depends. What are the trade-offs? And that is the right answer, to be honest. And a lot of the poor trade-offs you see in the software industry involve people actively not understanding these sources of complexity and often adopting packages or services they really don't control and they don't understand, which then loads complexity on the software that they're writing themselves. There's a lot to be said about the lower risk and lower complexity of maintaining 30, 100 lines of code that you control. You might be able to get it for free from a library, but if you don't take on the emotional labor and the burden of the upgrade cycle of that library and all the additional complexity, because dependencies introduce these extra surface areas into your code base, and all those extra features amplify complexity over time. And this is how we end up with the classic JavaScript left pad problem, where some random dependency that was taken for a fairly mundane thing got revoked and broke a lot of software. Now it's interesting because it's really an uneasy bedfellow with the conventional wisdom that you shouldn't really build software that you can buy. Every line of code is cost, everything you build you maintain. But I don't know, the example I always use is I recently wrote a 300-line static site generator rather than using one, because I spent an hour looking at the state of the art, and I was just like, God, there's just so much in here. I could have this done in the time it would take me to read the documentation. So I just wrote it myself. It was fine. I was just rendering 20 pages. It didn't really matter. My problem space was small, so I picked a small answer. All of your designs really should be expressions of that kind of trade-off. If you need one feature from a library, maybe write it. It's fine. Or copy it. It's fine. That's what open source is for, right? Now, in fact, once you start considering things as this kind of continual trade-off, what you realize is instead of rules around system designs, you end up with tests. And I don't mean coded tests or unit tests. I mean, you end up with design tests that you evaluate your choices on. I want to take you through a few tests that I use to select what I think a good design looks like. Now, this is my favorite test always, is can I do this with less moving parts? Now, a solution with less moving parts and less systems and less cognitive load is easier to rationalize, support, and maintain than one with more. Now, any additional moving parts, and this is where a lot of the pushback from people that have always built big systems comes against microservice architectures. There's just so much stuff. And every extra moving part is something that could break. And often, there's a good reason to choose a moving part, but it shouldn't just be the default answer. There are many places in our ecosystem where this kind of ballooning complexity makes working with systems just harder than they should be. So we should never extract parts of our applications to elsewhere just because. Just because is the dumbest reason. Never use it, right? So break up individual systems and components when they need to either ship, scale, deploy, or be maintained distinctly. Like, you only really break down systems when the usage patterns change. That's the important rule. Is this operable in a production environment? Again, lots and lots of cool things that people promote to me are just not operable software. They can't be maintained, they can't be upgraded, they can't be patched, they can't be observed. If you have a dependency that seems cool but isn't operable, it's just a burden and it will take your site down at some point. You can't pick it, you can't use it. So software where the design is difficult to configure or deploy, bad software. Is it easy to change? Now, the best software is software that's easy to change, because the only thing I can guarantee about your software is you will have to change it. One of the things I often have to talk about at work when dealing with kind of our stakeholders is that, they want us to get things 100% right where they can never have any errors. And I end up having these long conversations around the fact that I can never guarantee that any of our software will ever work. I can only promise that it will fail at some point. So that's actually the scenario we need to design for. So again, avoid over-design and focus on simplicity first. So I guess, as we come to the end of this, what I'm really advocating for here when I plead for intentionality is for you to write your software with care and with purpose. I want you to think about the design of your software. I want you to think about the reader. I want you to think about your friends. I want you to think about your peers. I want you to think about what form and flow means to the software. And I want you to use all of these forms of expression that are available to you in your code base to communicate meaning and intent. Different problem spaces and different solutions require different aesthetic viewpoints, and we should really embrace that, lest we damn ourselves to the two default designs, which is everything is a jumble of components and HTTP calls, or everything's an MVC app. And I don't want to work that way. So it doesn't have to be that way, right? And we can be better, because when you look at software that someone has built with care, it really shows. Like, it shows when you use a library and something is easy to work with, where the documentation makes sense. Like, I see you, all of you programmers, I see you when I see the effort that you put into the work. And like, I super deeply feel like this is our work. And I think back to myself as an art student, and like, that would have been my work. This is the work. So I was on a podcast a couple of years ago, and someone asked that really, really obvious, predictable question that always comes up. Oh, what would you tell to yourself 20 years ago when you were starting your career? And I always used to hate that question because I never had an answer for it. But now I know. Now I know. The answer is take more time. Take more time. All of the most beautiful things that I ever built, all the things that people loved the most, were when I finished and I sat and I just read the work. And I thought, what was I doing? Why did I do that? That makes no sense, because if I'm sitting there reading it and seeing that, everybody else is too, right? So all of the things that I've made that were ever beautiful, because I sat there and I read critically like a reader and fixed the things before anyone ever saw it. And I think that's super important. Just take time. It's beautiful. So I want to leave you with a couple of reading recommendations as we finish up here, partially because I don't really think there are many books on this topic, right? Design is something that's hard to talk about. All three of these books are really good. So there's A Philosophy of Software Design, which is John Oosterhout, which I've been quoting from in this deck. There's Your Code as a Crime Scene by Adam Thornhill. He's written another book that follows that up that also is crime scene-y, which is about understanding how your code has changed over time through kind of Git forensics, which is super interesting. And Code That Fits in Your Head by Mark Seaman talks in detail about kind of different ways that you can refactor through your code bases to make them more legible. They're obviously far more exhaustive than any one-hour conference talk could be on this topic, but they're all brilliant. I really do recommend you read them. And also support the authors in our community. It's nice, isn't it? So, ever seen a talk before that could be summarized as, fuck it, it depends? This talk. I like talking about things like design and language in literature, because when you talk about words, they mean things, and we grow our language, and then we can talk about them some more. I love talking about this stuff. Please hit me up. I hope this was interesting and gave you a bit of a different perspective on how to think about design than the regular, just do these 4 things and you'll be great and everything will be rainbows and kittens and, I don't know, other nice things. So, care. Thank you, please.